Hi, folks. Welcome to week 2 in DAX 601. This week, we are going to cover R basics and data structures, as well as importing data. So last week, we talked about RStudio, which is our IDE, as well as Cordo documents, the type of document that we write code in for our challenges in our final. This week, we're going to start actually digging into the code itself. I have 3 videos for you this week. This first one is going to be slides discussing all of the following. So things like packages, commenting code, data structure, logical operators. And then our second video, I'm going to go more in depth into those examples with an R basics example script. Then our third video will go through data import and an example called active duty marital example. First, let's talk about packages. So R is an open source language. And what this means is that people are constantly developing new code. They're creating new things for people to use with R. That means that no class can teach you everything because it's always developing. When people develop code to be used by others, these are called packages. And the idea is that there's a lot of background code and math that goes into functions that the rest of us can use. So tidyverse, for example, and we'll talk about that next week, tidyverse is the main package that we use in this course. And tidyverse has a ton of different functions that make data manipulation easier. The idea with packages is that you just have to install them once, and then you have to call them at the beginning of each of your documents. So your Cordo documents, or if you want to work in an R script, if you want to use a functionality present within a particular package, you just have to call that package to R's attention, essentially. It's very easy to do so. So the command is install.packages, and then what you need to do is put whatever that package name is in double quotes, and that will install it from CRAN for you. It's going to install it right into your R folders. Once it's successful, you'll get a message saying that the packages are in, and then whatever the file path is that your packages download to. Just because you install it doesn't mean that R knows that it needs to use it. So the next step is that you always have to call library and then the package name. And that, again, it just tells R, hey, I want to make use of these functions. So library makes it so that it's in its current memory. In this course, we primarily use tidyverse alongside these others. So for example, dplyr is great for tidying data, purrr is great for functions, string R is great for working with strings, and so on. But if you're curious about other packages beyond tidyverse, there's tons. And the great repository is CRAN, so the Comprehensive R Archive Network. You should recognize it because this should be where you downloaded R. And you can click over here to find the different packages. Click on packages. I like to sort by name. And there's just what feels like an infinite amount of packages that folks have written. So for example, let's say I want to use this one, genetic association studies. I'm not sure what that means, but we have a clear description up here. And then often we have something like a reference manual. So here's a PDF that has details about every single function in this package. And then sometimes there's also, and I don't see it here, there can be demo code as well. You can scroll through, try to find there's data sets, there's packages with very, very specific tasks, and so on here in CRAN. But I don't expect you to go searching for packages in this course. We will tell you exactly what packages you need to use. It's just helpful to know that there's a lot more out there. Let's say you are using a package and you don't feel like navigating all the way to CRAN. What you can do is just type a question mark in your console and the package name, and information about it should pop up in the help menu in the bottom right quadrant of RStudio. So you're like, I wonder what else dplyr can do, for example. Type question mark dplyr, and this will pop up here. Let's say you want to know more about a particular function within dplyr, for example. You want to know more about mutate. You've seen me use it, and you're like, wait, I'm confused. Type in question mark mutate, and you'll have a description of this function and often, again, examples that shows you the different arguments that you can put in this function. One thing to note, if you want to look up a function, make sure that the library that it's part of or the package that it's part of is loaded first. In terms of R basics, a really, really important thing is code style. And one key part of that is commenting your code. You should always describe what you're doing in your code. And in R, you do this using the hashtag. So for example, here, every line I've described exactly what it is that I'm creating. I describe how I'm assigning a string value here, or I describe what this function does. I don't expect you to comment every single line, but I do want you to be regularly commenting your code, explaining the logic of what it is you're doing. This is helpful for your instructional team, so we can award partial credit and so we can get a sense of what it is that you're thinking. It's also helpful for you. The whole idea of using scripts, of using Cordo documents, is that you can come back to this in the future. You can reuse your code. And it's really, really helpful when you've commented exactly how this code works, because chances are that future you remembers exactly what you did is really slim. And I can confirm that having gone through DAX. I've showed you the source view before in Cordo, so this is the typical view that you're going to be using. I recommend that you always code in source view because you see the numbers. So these numbers along here, let's say you throw an error, it's going to tell you error at line 13, for example, and then you can easily refer back. The comments themselves, they look the same. So you're going to want to put your comments in your code chunk. Your visual view takes away those line numbers, but it can help you with formatting your text. So the text that goes beyond the code chunk, so the text that's outside of this code chunk that's indicated as R, that is where you can edit that a little bit better. So let's say you want to make a bolded list or you want to make a heading, you can edit in Visual View a little bit easier. But the whole point is that I want to make sure that you're commenting lots. Comment exactly what it is that you are trying to do with most of the lines that you're working with. Another really, really important thing is naming. So your names should be in lowercase. And I say this because R is case sensitive. So Larry with a capital L versus Larry with a lowercase l is a completely different variable in R. It's easiest if you use lowercase just because it prevents you from making a mistake. But if you prefer camel case or if you like using capitals, that's fine. Just know that it's case sensitive and that you don't want to make a mistake in that way. You should only use letters, numbers, and the underscore here. And critically, if it's entirely numbers, R is going to be confused. And there is an example in tutorial 2 about that, tutorial 1 or 2. But make sure that you're just using those types of values. And then you want to make sure that you're descriptive. So again, the idea is that you can reproduce this code. The idea is that you can come back to it. If you just say blah, I don't know what that means. Whereas pet names is descriptive. So let's say pet names is a list of different pet names that you have. That's descriptive. Blah? What is that? So these are incorrect because there's a space here. So R is going to throw an error. And then blah is not descriptive. But something like pet names, that's the type of name that I want to see in your code. There's a bunch of different data types in R. We have numeric types. And so numeric covers things like 10 or decimal places or 150,000. Those are all considered numeric. There's also integer type. So integers, as we know just from regular math, integers don't have decimal points. In R, they're denoted with an L. So if you want something specifically to be an integer, you have to type L after it. Complex are numbers with an imaginary component. We're not going to be using them in here, but that's how you denote that with an I. Characters. Characters and strings go together, and people often get them confused. A character is a single value. So it's A, it's 1, it's at. And critically, it's in those double quotes. So R reads anything within double quotes as character type. So even if it looks numeric, that looks like 1, right? No, it's in double quotes, so therefore R says no, that is a character, and it won't recognize it as an integer unless you change it. A string is a set of characters. So a string is when you put a bunch of letters or a bunch of things in quotes together. So hello, a word, is a set of characters, therefore it is a string, or a sentence is a string. But a string is composed of individual characters. And then a logical is just true or false. So those are the ones that we'll be working with. In this course, numeric, characters and strings, and logical is primarily what we'll work with. Let's say you don't know what a particular variable type is. You see a variable, you don't know, oh, is this a string? Is this a numeric? Is this a logical, for example? You can very easily check that using class. So all you have to do is type class, and class is a function. Anything that you have the verb, I like to think of these as verbs, so class or mutate or those sorts of things. Anything with those parentheses, that's typically going to be a function. And what this function does is it tells you the class type of whatever variable that you feed it. So for example, here we have a logical variable. When you type class, it's going to tell us in the console that the class is logical. And this is helpful again if maybe you think that a value is numeric, but it turns out that it's actually behaving like a string. You can figure out, oh, that's where my problems are coming from because the class is different from what I expected. Let's say you're in that situation, you want to change it. What you can do is use the as type function. And what this is just as dot, and then whatever class type you want to change it to. So numeric or integer or character. I have factor with asterisks because it's a bit more complicated, and we'll get into it later. But let's say you want to change a numeric to a string. You use as.character, and there you go. Data structure is really important. So data, you can think of structure as the form that data takes. So, we've talked about some basics of maybe how you name your data or how you look at the type of class it is. Now we're thinking about how do we structure data for our analysis. So data structure, just a way to organize and store your data. In R, the basic structures that we'll encounter are vectors, matrices, arrays, data frames, and lists. And I'll go through each of them for you. A vector. Critical to a vector is that all elements have to be of the same data type. So a vector is essentially a list, so these words feel very interchangeable. A vector is a list of just a specific type. And you create that using C. I like to think of this as combine every time I see it, or concatenate is another way that you can think of it. But C, everything within that C is going to make a vector. And here's an example. Let's say I just want to store a list of names or a vector of names. I know that I want everything to be the same. I want everything to be a character class. And so to create that list, what I do is C and then the different values. So these are just different pet names of pets that I've had. And what I do here, I have a very descriptive variable name and then my vector. Same thing with integer. You can do the same thing for any of the variable types. And we'll go through this example soon. Let's say that you accidentally have more than one type of variable, one data type in the vector, more than one data type in your vector. R is going to coerce that vector to be of a single type. So you say, oh, I want integers and strings. It's going to say, too bad. Everything is now of character class, or it's all going to be strings. So in this example, I have hello, which is a string composed of characters, 18, a numeric value, and true. When I checked the class, R said absolutely not. These are all characters now. Typically, if you have one string or character in the vector, it's going to convert everything to that because that's just easiest. It's easiest to treat everything as if it has those double quotes around it. So just beware of vectors. It's just a single data type. Now factors. Factors are specifically used for categorical variables. And they're great because they have a fixed and known set of possible values. So for example, think about the different levels in college. You have freshman, sophomore, junior, and senior. Those are fixed set categories. We know there's only 4, or maybe you add in a 5th and just call it other. We use factors because they allow you to order those different levels and make explicit, again, the exact number of levels that are possible. This is really helpful when it comes to visualization down the road, which is the second half of the course. You can make it so that your graphs show freshman, sophomore, junior, senior, and so on in the order that makes sense. And so this is specifically with categorical variables. And here I have an example that we'll run through in the next video. Data frame. Data frames are really, really common. So in a data frame, I like to think of it as just an Excel sheet. It's just R's version of an Excel sheet, and that's something that most of us are familiar with. The idea is that your variables are the columns. So things like, in this example, name and type, maybe age, maybe hometown, whatever, different variables. The cases are rows. And what I mean by cases is in this example, I've named out different pets again. So I have George, Brian, so on. And each column after gives me an attribute about them. So it says George is a rabbit. If I wanted to add in an age column, it would say that George is 3 years old. Or if I wanted to add coat type, he has fur, or whereas like the fish has scales, and so on. But each row represents things about George. And then each cell contains a value. So that value being George or rabbit or fur or scale or 3 years old or so on. Data frames are really important, and they're the primary, like most of what we're going to work it with in this course is in data frame format. The next type is list. A list is a vector that can have different variable types. So it's less fussy than vectors in that way. When you want to create a list specifically, you use the list function. So instead of C, you say list. What differentiates lists versus vectors beyond just the single versus multiple data types is that each value in a list can hold another list. So you can have nested lists. And this looks like this, where we can have this list, contains these different elements, but each element can also, you can nest those, so it has even more lists. Not super common in this course, but it's still helpful for you to know about. Most data sets are not perfect. Most data sets are going to have missing values. And in this class, we take missing values seriously. So I don't want you to replace a missing value with a mean or something like that, which might be appropriate in another context, but it's not appropriate here. Here, we can be curious about if there are trends in what types of data are missing. But the idea is that in R, missing data is represented with NA. And I want to be very clear that NA is not the same as quote NA. Quote NA is just a string. R treats NA as a very specific thing, that thing being missing value. So for example, here I've created just a simple vector of numeric type, and I slapped an NA, a missing value, in the middle. If you want to just check if there is missing data in your data set, you can use a function called is.na. And what this does is it runs through every line in your data set, so every cell, and it just checks, is this NA? If it's not NA, it spits back false. If it is NA, it spits back true. And so we see here, in my example, the third value is an NA. The third logical output is true. It's telling you, yes, there is an NA value there. And it's important to note this doesn't change the data. It's just telling you information about it. So it's not replacing that NA value. In tutorial 2, you're going to learn about summarize. And one of the things that summarize does really nicely is it helps you calculate things like means. Now, you can calculate means without using the summarize function, but this is where you'll encounter it in the tutorial. Anyways, when you run a mean on a variable or a column that has NA values, it's going to spit back NA. It's going to say, no, I can't calculate that because NA is not numeric. I can't fold NA into the mean. What you can do to get around that is just set an argument called na.rm to true. And so this example, this is a function. Mean is a function. We say mean, we tell it in this case, vector. It could be a particular column. It could be a list, whatever. We're saying we want you to take the mean of this. And we're saying, okay, let's add in an argument that we want you to ignore any NA values. That's what NA.rm equals true. As you get more comfortable in R, you'll encounter more of these. Lots of these functions have arguments that you can play with. So you can decide, do I want to ignore NA values or do I want to keep them? And all you have to do is just adjust true versus false. And that's one of the things that doing the question mark or looking up these different functions, you'll see there's lots of arguments that you can add in. Moving on to accessing specific elements. So if you've coded before, you've probably encountered atomic indexing. And the idea is that you can pull out or isolate specific parts of whatever data structure you're using. So maybe it's a list, maybe it's a data frame, maybe it's a vector. What you can do is you can say, okay, wait, I only want this particular piece. And you can use either subset, which we'll get to, or this. And the idea is that you use these square brackets to indicate what exact element that you want. And when I say element, here we have the pet names vector again. George is the first element. Brian is the second. Button is the third, and so on, however many elements there are. One thing to note is that R does index at 1. Now, this is different from other languages. Other languages index at 0. So the first value is considered at 0, not R. R indexes at 1. So the very first one is at 1. And let's say I just want to pull out that first value. What I can do is I can type whatever the data structure name is. So animal type or Larry pet names. I say I want to use 1, and it pops out just that individual cell. You can do the same thing for a data frame. And so a data frame, it's multi-dimensional instead of single-dimensional. And here we have an example of a variable called name and a variable called type. Let's say I just want to pull George out from all of this data. The way this works is you start with the row. So this is row 1 here. This is row 2. This is row 3, and so on. And then I indicate what column. So if I just want George, well, he is at row 1, column 1. If I just want to pull out the cell called rabbit, well, that's at row 1, column 2. So that's how you read this. It's always row, then column. And let's say that you want to return an entire row or an entire column or multiple columns. What you can do is you tell R the data structure name. So is it a vector? Is it a data frame? So on. You use your square brackets. And if you want all of the rows and just the first column, you don't indicate any number for row. You just put a comma and then the column number that you want. And then let's say you only want that first row. You only want the information about George in this case. You say, okay, I just want the first row. And the comma with nothing after it indicates that you want all of the columns. If you want just a specific column, you can use the money sign and then pull the column name. So let's say in this example, I have Larry Pets is my data frame or my vector. It is my data frame. Sorry. And then I just want the name column. If I use that money sign, it's going to pull just that column, just that variable. You can also do this with logical operators. Let's say you don't really like dealing with the square brackets. Instead, you can use subset to select specific elements just based on that cell value. And R uses similar logical operators to what I'm sure you've encountered before. So equal equals, that means is equivalent to. Every time I see the double equal sign, is equivalent to. Not the exclamation point equals, that means is not equivalent to. And then we have our classics, less than, greater than, and then less than or equal to has the equal sign. The ampersand means and. The vertical line means or. And then let's say you have a lot of ors. So you're saying, okay, I want to pull any data that is reptile or fish or mammal or insect or on and on. What you can do is use in. So quotient. I'm blanking on that. We're moving on. In, and that can replace the multiple vertical lines. You know things until you try to record a lecture, I'll tell you that. So an example of subset, and we'll go through this in the code example. Let's say I just want type fish or type snail from my pets data frame. I can say type is equivalent to fish or type is equivalent to snail. And another way, type in then a list of fish and snail. And again, tutorial 2 is going to cover summarize in depth. The idea of summarize is that you create a new data frame that summarizes information about your existing data. So things like mean or interquartile range and so on. And we'll show you how to do that in tutorial 2. Our next video, we're going to run through all of this information again, but in the form of an R script.